used to visualizing AI as a flawless current of information. Text goes in and analysis pours out. In our last episode, we explored agent number 10, the data analysis agent. It's built to take raw data and turn it into polished charts and confident narratives. But right next door on our architectural map, sitting squarely in the data analysis and reasoning tier, is agent number 11. It acts as the safety net for that data analyst. This placement matters because generating an answer and trusting that answer are two completely different computational jobs. Agent 11 is the verification and validation agent. It generates 0 new insights of its own. Its sole purpose is to interrogate the insights produced by the rest of the system. Without this interrogation, enterprise systems suffer from silent error propagation. A flawed number or a misread chart slips into a summary, moving untouched into downstream workflows. Imagine a large language model summarizing a financial quarter. It reads 120 million in revenue and 100 million in costs. Then it confidently types out a healthy profit of $30 million. The sentence is grammatically perfect and completely wrong. That disconnect makes an AI's linguistic confidence the single most dangerous metric in data analysis. Fluent generation is easy for a language model. Factual correctness is hard. A medical triage agent, for instance, might draft a pristine clinical summary that suddenly surfaces a drug interaction directly contradicting its own recommendation from 2 paragraphs earlier. As of 2026, these hallucinations remain the absolute largest barrier to deploying autonomous pipelines into production environments. The engineering solution is structural. You cannot ask the agent that wrote the report to fact-check its own report. You have to separate generation from evaluation. Agent 11 treats every generated statement as a hypothesis to be empirically tested, rather than a fact to be trusted. Think of it like a newsroom. The data analysis agent is the anchor reading the teleprompter. The validation agent is the invisible fact-checker in the backroom who already reran all the numbers before going to air. A transparent dual-agent audit trail provides a structured mechanism to verify black box models before their outputs influence an operational decision. To see how this audit trail operates, look at this 5-stage trust gate architecture. It intercepts claims before they reach a human reader. It starts with claim decomposition. You cannot fact-check an entire paragraph at once, so the agent splits the prose into discrete atomic claims. Each sentence is isolated, ready to be tested against a trusted external database. In Stage 2, the agent formulates specific search queries to retrieve hard evidence. This diagram outlines the core of that process, natural language inference, or NLI. The NLI model acts as a judge, comparing the extracted claim against the retrieved source documents. NLI forces the relationship into one of 3 strict categories. It stamps the claim as supports if the data confirms it, refutes if the data contradicts it, or neutral if the documents are unrelated. When multiple databases disagree, the system evaluates the conflicting evidence, weighs the credibility of each source, and calculates a final confidence score. This fact-checking stage forcibly shifts the system away from probabilistic word guessing and grounds it in deterministic evidence matching.
Moving back to the trust gate, Stage 3 handles logical coherence. Here, the agent moves past individual facts to investigate the actual reasoning structure. The agent maps the paragraphs into directed graphs. Each premise points to a conclusion, exposing structural fallacies like premise-conclusion mismatches. This visual mapping makes circular reasoning instantly detectable. It catches the AI equivalent of a dog chasing its tail, where a claim relies on itself for support. This is also where we solve the $30 million math hallucination we saw earlier. The agent strips the arithmetic out of the language model entirely and feeds it into a symbolic math solver like SymPy. The symbolic solver catches the hallucinated $10 million discrepancy, precisely because it cannot guess. It can only compute the exact mathematical formula. Offloading computation to a dedicated, rigid calculator provides a reliable method for preventing the mathematical hallucinations common in large language models. Stage 4 applies consistency and red teaming. The agent runs deterministic checks and initiates adversarial red teaming, deploying secondary models to expose hidden bias. Finally, the data hits the confidence gate. If flagged, the claim is routed down the revise path, sent back for automated self-correction without requiring human intervention. In Chapter 8's Python implementation, this theoretical architecture translates into a hard-coded workflow. Here, we see the claim extraction function directly invoking the NLI model. Further down, the script implements the symbolic math solver and defines the critical confidence threshold variable. This precise code turns theoretical safety guidelines into a hard, programmable barrier that simply cannot be bypassed by any hallucination. These exact barriers are now being deployed in high-stakes enterprise environments where a single error is too expensive to ignore. In finance, the validation agent audits automated earnings summaries, running the numbers before they ever reach an executive dashboard or a public filing. In clinical and legal sectors, it acts as a strict quality gate for any generated insight that could result in a critical, real-world decision. However, the system does have a primary architectural limitation: the risk of false confidence in the checker itself. Agent 11 is completely dependent on the quality of its retrieval pipeline. It is only as good as the evidence it pulls. If a specific claim cannot be settled by a trusted database, the validation agent cannot magically verify it. Passing the confidence gate signifies that strong evidence was found, not absolute divine truth. It is a rigorous audit, best deployed where the cost of being wrong is high. Agent 11 fortifies the data analysis tier by ensuring system outputs are defensively correct and grounded in verifiable evidence. Next time, we move to Agent 12, the general problem solver, which builds upon this rigorously grounded foundation to tackle entirely novel scenarios. All the code and architectures discussed today are detailed in the sourcebook, available on Amazon and from Pact. For more visual engineering breakdowns, visit neuralsca. This verification process provides the transparency needed to turn speculative model outputs into actionable, reliable evidence.